So we're continuing with our stats in 5.7. We're looking at scatter plots and trend lines. We're going to look at an equation of a trend line and line of best fit, pretty closely related, and also use a trend line and line of best fit to make some predictions. So first of all, we're going to skip through that first problem. You can look back at it, especially after we cover this, and see if it makes a little bit more sense. But we can determine whether two sets of numerical data are related if we graph them as ordered pairs, so XY pairs. If the two sets of data are related, you may be able to use a line to estimate or predict values. We're going to be working on making those lines in this section. A graph that relates two different sets of data by displaying them as ordered pairs is a scatter plot. Most scatter plots are in the first quadrant of the coordinate plane because we've seen that data are usually positive numbers. So usually if we're measuring something in real life, it don't deal with a lot of negatives. You can use scatter plots to find trends in data. Scatter plots are going to show the three types of relationships that two sets of data may have, and these are the three. So when y tends to increase as x increases, so just think if you have a positive sort of slope to your data, two sets of data has a positive correlation. So again, positive slope goes up as we go to the right, so does a positive correlation. If I switch that, so if y tends to decrease as x increases, two sets of data has a negative correlation. So as one increases, so as x goes up, y goes down, or vice versa. As y goes up, x would go down, although we don't really go backwards for x too much. So same thing with a negative slope. A negative correlation is going to go down as we go to the right. When x and y are not related, the two sets of data have no correlation. So that's not really going to look like a pattern. It should just look like a bunch of random points with no clear pattern going upwards or pattern going downwards. I can't really make any sort of line through those. So using that, we're going to make a scatter plot of the data in this table below. We want to say what type of relationship the scatter plot shows. And I graph my data actually with the gallons bought along your x-axis and dollars spent along your y-axis. Although these I think you can probably flip and do the same thing and you'll see the same correlation. But if I just enter those points, again, if dollars spent is 10, gallons bought is 2.5, so 2.5 and 10 would be about right there. If I buy 2.8 gallons, that's $11, so 2.8 and 11. And entering all these points, again, is just XY pairs. I chose gallons to be X and dollars spent to be Y. Just want to make sure you graph those all as ordered pairs. So again, if I finish with 1.1 and 4, 1.1 gallons, $4, that would be that point there. So just make sure you fit all those points as ordered pairs. And then you don't need to make a line through them, but all you have to do is look at that slope that would be formed if I did draw a line. Since my data seems to be going upwards, as gallons increase, so does the dollars spent, which makes sense. You buy more gasoline, you should spend more money. That does have a positive correlation. They're both increasing at the same time. Consider now the population of a city and the number of letters in the name of that city. We got to expect either a positive correlation, a negative correlation, or no correlation between those two sets. And I would think that they would have no correlation there, again, between the name of the city or how long the name is and how many people live there, because name length of a city doesn't really affect how many people choose to live there. Not really going to move to a city because of the name length, and vice versa. Number of people living there, it's not going to change the name of the city. So those would have no effect on each other. They'd have no correlation. When two sets of data have a positive or negative correlation, so as long as they have some sort of correlation, we can use a trend line to show the correlation more clearly. So kind of like in that last problem, if I would have just drawn a line through those points, you could show basically that trend, which we already saw. A trend line is a line on a scatter plot drawn near the points that shows your correlation. So just like that last graph, if I have a positive correlation, I'd be drawing a line with a positive slope. If I have a negative correlation, I'd be drawing a line through them with a negative slope. Just try and fit the line as close as possible to the points. Not going to be an exact line if we're just choosing our line, but our trend line, you just want to estimate where your data is headed. So you can use a trend line to estimate a value between two known data values or predict a data value outside the range of the two, or outside the range of your known data. So that first part, estimating, call that interpolation. So it's between two known values. So interpolation, you want to think inside your data. Extrapolation is where you predict a value outside the range of known values. So I think a good way to remember that extrapolation is some extra values either before your data or after your data, but not within the data values. So we're going to try and do that on this practice question. We're going to make a scatter plot just like that last question of our data table. This time though, we're going to add in a trend line and write its equation. We're also going to use that trend line to estimate the body length of a 7-month-old panda. And if I look at my data, I have ages for basically everything up to 9 months, but it's missing 7. So first thing you want to think based on those definitions, if I'm trying to estimate, again, a 7-month-old panda's size, that would be an example of interpolation because that's inside of my data set. That's not outside of 9 months or before 1 month. So first thing you want to do, just like that last question, is graph these all as XY pairs. So I graphed age along your x-axis and body length along your y-axis. So if I treat all of the age as x's and the body length as y's, first of all, you just want to make sure you have all those points plotted in there and get them as close as possible to your scale. Next, you're just going to draw in a line, and I drew my line going through about the middle, which, again, you're kind of estimating this anyway, so you might have a different line from somebody else doing it. But you just want to draw basically as smooth as you can through all of those points. Try and have an even number of points below and above that line. And if you're then trying to make an equation for that line, what we have to remember is that your line equation is going to be y equals mx plus b. And in order to find that, it helps, I think, to estimate using a couple points. So I chose a couple points that looked like they were pretty close to my trend line. So I had a point at 2 months that was 11.75 inches, and at 6 months that panda is 22.2 inches. Those are the closest points to my line. So if I use those 2 points, remember if I want to find the slope of my line, I just have to use the slope formula. So y2 minus y1 over x2 minus x1. If I simplify that, that eventually gets us a slope of about 2.61. And again, all of this is estimation, so it doesn't have to be terribly accurate, but as long as you have a good guess for this, you're looking for something close. So now if my equation has the slope written in it, so 2.661x, I still need to find an intercept. And again, you can kind of estimate the intercept based on your graph, but I'm just going to find the intercept exactly using our points. So if I plug in one of those points, if I plug in this one, for example, x is 2, y is 11.75, I plug in 2 for x, 11.75 for y, and I can use that to solve for b like we did in that first semester. So subtract and isolate for b. We get this intercept is about 6.53, which looks maybe a little bit lower than I have it on my graph, but it's still a pretty good estimate. So if that's my trend line equation, our slope is 2.61, our intercept is 6.53. Again, it doesn't have to be exactly the same as mine, as long as it's relatively close. You don't want to have a slope of like 5, for example, or an intercept of like 15. You want it to be pretty close to those values. I can then use that to estimate a 7-month-old panda by this time plugging in, instead of x, I'm going to substitute that with a 7. So if I'm looking for the panda's size at 7 months, you can also estimate just kind of looking at your graph, so it looks like it should be around 25, but if I plug that into my equation, I can get a little bit more exact guess. If I plug in 7, I get about 24.8, so we can use that as an estimate for that panda size at 7 months. So using my trendline equation, plug in 7 for 7 months, and that gets us our estimate for the panda's length. We're also asked a question, last time we did interpolation on that last question, but we're also asked, do you think we can use our model to extrapolate the body length of a 3-year-old panda? Seemed like we should be able to if I just extend that line, but you have to be careful here. If I'm thinking of a 3-year-old panda, that's pretty far away from our data. Our data ends at 9 months. So I'm going to say no. I can't use that same equation to extrapolate because pandas are going to grow at a slower rate as they age. Compare how much you were growing as a kid or as a baby. You probably grew a lot more than as you age and get older. So you can estimate around the data set, but you don't want to go too far in either direction for an extrapolation. A trend line that shows the relationship between two sets of data most accurately is called the line of best fit. Again, we were kind of making trend lines, so a similar sort of concept, but a line of best fit is going to be a little bit more exact. Graphing calculator computes the equation of the line of best fit using a method called linear regression. And we're actually going to skip the next part of this. It's a little helpful just kind of understanding. Remember, we have no correlation, we have positive correlations, negative correlations. So we're not going to be asked to do any work on a graphing calculator. You do want to be familiar with the concept of correlation, though, which we saw a little bit earlier. But I do want to skip down and talk about causation. So causation is when a change in one quantity causes a change in another quantity. A correlation between quantities does not always imply causation, and we'll see that in these next couple examples. So just because two things are related doesn't mean one has to cause the other. In following situations, is there likely to be a correlation, and if so, does a correlation reflect a causal relationship? And we've got to explain. So again, correlation could exist without something causing the other, and I think we see that in the first example. So the cost of a family's vacation and the size of their house. So this would be an example where these would be correlated, but one is not causing the other. So yes, I would say that families who can afford more expensive vacations, so that as the cost of their vacations go up, you're probably also likely to live in a larger house, because if they can afford a larger vacation, they can afford the larger house. I would say, though, that there's no causation there. One's not causing the other. The size of their house doesn't affect the vacations that they take. It's just the fact that they can afford the bigger vacation, they can afford the bigger house. So they are correlated. Our next example, though, is an example of causation. The time spent exercising and number of calories burned. I would say, yes, there's a direct causal relationship. So they're correlated and there's a causal relationship. Since the more time you spend exercising, that directly affects how many calories you burn. So one does directly affect the other. We have a cause and effect. So make sure we have these notes completed, and again, I'll check these and see if we can add some stuff in class.